At section 1.2, I can work with fractions. So we reduce fractions always. We're going to look at adding and subtracting of fractions, multiplying and dividing of fractions, and we've already done applying fractions by dimensional analysis with our add puzzle. So we're going to stick with these first three. Reducing fractions. It may be reduced to simplest form when the numerator and denominator both have a common factor. So if the same number goes into both numerator and denominator, you can divide it out. The fraction 4 over 6 may be written as 2 times 2 over 2 times 3. So they have a factor of 2 that can be canceled out. So it's simplified down to 2/3. Or you just see that 2 goes into both those and divide. Really what we did. Number 1, we should know that 7 goes into 7. And 7 goes into 21 3 times. So it's 1/3. Because 15 and 40 and in 5 and 0, we know that 5 can go into both of those numbers. 15 divided by 5 is 3. 40 divided by 5 is 8. Number 3, 5 and 21 cannot be simplified. 5's prime. 21 only has 1, 21, and 3, and 7 that are factors. So we can't do anything with that. However, we have an a in the numerator and an a in the denominator, and they cancel out. And then that's it. Only have b in one place, only c in one place, so there's nothing else to go with it. Number 14, again, we're going to look at the negative 14 over 28. Now, these can be simplified both by 14. And now our y's cancel out. So I got an x in my numerator, I got a z in my denominator. You can write it like this with a -1, or you can just write it like this. Either way, those are the answers. Number 5, again, we want to cancel out factors. Well, it's x plus 5 times 3 and x plus 5 times 9. So the x plus 5's cancel out. We're stuck with 3 over 9, which of course we can simplify down to 1 over 3. And number 6, there's nothing that goes into 4 and 11. 11 is prime. 4 only has factors of 2, 4, and 1, which don't go into 11. So that's as far as we can go. So that's reducing. And we always have to simplify or reduce our fractions. Now, adding and subtracting functions, key thing here is we need common denominators. They don't have to be the lowest common denominator. They just need a common denominator. To add and subtract fractions that have different denominators, we need to write all the fractions so they have the common denominator. The easiest way to do that, if you're stuck, multiply the denominator to get the common denominator. Then add or subtract the numerators. Always reduce your fraction answers. So number 1, they have the same denominator. So now we're just doing 2 minus 10, which is -8. And our denominator is 3, so we keep it as 3. When we work to get the same denominators, we keep the same denominator. Well, in number 2, they're different. So what number does 3 and 4 go into? 12. It's also 3 times 4, so it should have been obvious that that was one of our numbers. Now, what did I multiply by to get from 4 to 12 in the denominators? 3. So it's 3 times 4 is 12, 3 times 10 is 30. So 30 over 12 is the same thing as 10 over 4. Now, what did I multiply to get 3 from the denominator in the first fraction to 12? Times 4. So 4 times 2 in our numerator is 8. Now we add up our numerators. And then we can simplify. We are going to divide by 2. And we get 19 over 6, or 3 and 1 over 6. I don't care which way you write it, as long as it's correct. Now, number 3, it's going to be kind of messy, because we have 3 denominators that are not the same. So the easiest way to do this, 5 times 2 is 10, times 7 is 70. So in the first one, 1 over 5. 70 divided by 5 is 14, or in other words, 14 times 5 is 70. So 14 times 1 is 14. Our second fraction, 70 divided by 7 is 10, or 10 times 7 was 70. So 2 times 10 is 20 in our numerator. And then 70 divided by 2 is 35. So we're multiplying 2 times 35 to get 70. 3 times 35 is 105 for our numerator here. Now it's pretty straightforward. 14 plus 20 minus 105, negative 71, over 70. Or you can do it as a mixed number. But I think improper fractions are probably easier to look at. Our last one up here, 3 over 4. Remember, minus a negative turns it into plus a positive. So it's really plus 2 over 5. And then we have 2 cubed, which is 8. If we want to make a whole number, like 8, a fraction, just put over 1. So what number, kind of cheating here, getting ahead. The biggest number, the number that 4, 5, and 1 all go into is 20. Or you could use 40 or 60. It doesn't matter as long as all of the numbers go into that. So 20 divided by 4 is 5, so we multiply by 5 here. In the second one, 20 divided by 5 is 4, so 4 times 2 gives us 8. And then the last one, 20 divided by 1 is 20, because 20 times 1 is 20. 20 times 8 is 160. So we add all those up. We get 183 over 20, or 9 and 3 over 20. Again, both of those are fine. Hopefully adding and subtracting is pretty straightforward. Got to find that common denominator. Now, when we go to the back page here, get a different color, so a little bit more dynamic and colorful. Multiplying and dividing. Common denominators are not necessary. In fact, they make the problem a little bit harder. We have 2 different methods to multiply. One is we multiply first and then simplify. 2, we simplify and then multiply. And you're going to see that it doesn't really matter which way we do it. So method 1, 3 times 10, or 3 over 10 times 5 over 4. So our first method is to multiply first. So we just multiply straight across. 3 times 5 is 15. 10 times 4 is 40. We can simplify that by 5. So we get 3 over 8. Whoop. Not too bad. If we were to do it the other method, where we simplify first, nothing goes into 3 and 4. So we're cross simplifying. Now 10 and 5, we know 5 goes into both of those. 5 goes into 5 once, and 5 goes into 10 twice. Now we multiply across. 3 times 1 is 3. 2 times 4 is 8. Whoop. And we got the same exact answer for method 1. So it doesn't matter how you do it. Most likely we'll be using a calculator to multiply across, so it doesn't really matter. Number 1, we need to multiply, again, just straight across. We have parentheses, but it's still just multiplication. So when we multiply, 6 times negative 5, we get negative 30. And 35 times 16 is 560. So both of those end in a 0, so we know we can divide by 10. So it's negative 3 over 56. Now number 2, not a big deal. We just have to multiply all the way across. So 2 times 9 times 5 is 90. And 3 times 20 times 12 is 720. Again, they both end in 0, so 10 can go into them. But if you look at the 9 and the 72, 9 is a factor of 9, of course. 9 is also a factor of 72. So really the biggest number that goes into 90 and 720 is 90. 90 divided by 90 is 1. And 720 divided by 90 is 8. Oh, and it's negative because we had the negative here. Doesn't change the problem. We just have to make sure we put it with our answer. Number 3, we need to turn 8 into a fraction. So 8 times 1 over 14. This time I'll do the cross simplifying first. I think it'll be quicker. So we know that 2 goes into 8 and 14 because they're even. So we get 4 over 7, or 4 and 7. Then 4 times 1 is 4. 1 times 7 is 7. And we got our answer. We can't simplify that. 7's prime. So that's our multiplication. Division is not too much different. In math, we like to be lazy and change problems we do know or don't know into problems we do know. So to divide fractions, you multiply by the reciprocal of the second fraction. I don't know why it says denominator. Always reduce your fractional answers. So in other words, for number 1, we want to divide 1/3 by 4 over 7. So it's 1/3 times 7 over 4. That's our reciprocal. We just flip it upside down. Multiply straight across, like we were doing above. Nothing goes into 7 and 12. 7 is prime. We're done. That's it. Number 2, I'm going to write it out like this because I don't want to do too many steps at once. Not yet anyways. So it's 3 over 5 times 8 over 9. We can simplify or multiply across there. So 24 over 45. And we can divide by 3. So 8 and 15. Number 3, again, same idea. We need to turn 4 into a fraction. So it's 4 over 1. So 2 over 5 times 1 over 4. Just flip it. So we get 2 over 20 when we multiply straight across. We know that we can divide by 2. So our answer is 1 over 10. We got a couple more practice. They're not done any differently. So 7 over 9 times 27 over negative 14. We'll just keep the negative with the 14 because it doesn't matter. Now let's cross simplify. Again, I think it's going to be quicker. 9 goes into 9, and it goes into 27 3 times. 7 goes into 7 1 time, and it goes into 14 twice. So now we just multiply across. Well, 1 times 3 is 3. 1 times 2 is 2. And the whole thing is just negative. Doesn't matter if you put it with the 3 or the 2 or just out front in general. It is a negative answer. Same with number 5. We have a negative divided by a positive. It's going to be negative. But 11 over 24 now times 12 over 7. On this one, we'll multiply it out. 11 times 12, negative 132. 24 times 7, 168. And it's important to be able to find factors pretty quickly. They're both even, so I know I can divide by 2, but we can divide even more. We can divide by 12. Again, it's just trial and error. So negative 132 divided by 12 is negative 11. And 168 divided by 12 is 14. Again, 11's prime, can't do anything with it. Maybe at number 5, we probably should have done the cross canceling because those numbers got kind of big. And it's a little bit hard to see what goes into 132 and 168. Number 6, 1 over 6 times, I'm just going to skip that next step. Hopefully we're okay with that. So it's multiplication by the reciprocal. I didn't write out the division again. Here, I'm going to cross simplify. 6 and 27 has a common factor of 3. So it goes into 6 twice. It goes into 27 9 times. Then we multiply across. 1 times 9 is 9. 2 times 32 is 64. That's our multiplying. There's nothing too crazy going on there. Now, that's not to say that 7, 8, and 9 aren't crazy, because they are. They're not easy problems. So let's take a look at number 7 first. Well, we have to do 3 over 1 plus 2 over 3 first. And then whatever answer we get, we'll divide by 11 over 16. Well, we need to multiply the first fraction by 3 to get our denominator of 3. So that we have 9 over 3 plus 2 over 3 divided by 11 over 16. So that's 11 over 3 divided by 11 over 16. And make sure this middle fraction bar is bigger than these guys so we can tell it's the fraction divided by a fraction. And again, I'm not going to write down the step with the division. 11 over 3 times the reciprocal of our denominator there. And obviously, we cross cancel out the 11s. We get 16 over 3. Or, if you really want, 5 1/3. Number 8, we do the order of operations. So we're doing 2 over 3 times 9 over 5. Well, again, cross canceling, divide those two diagonals by 3. 2 and 5 are prime. So when we divide this middle number, we get 6 over 5. Now we still have to do 1/2 minus that and plus 5 over 6. So we need a common denominator for 2, 5, and 6. Again, you can multiply 2 times 5 times 6. That's 60. That's kind of a big number. When 30 will do. So however you want to look at it, it's fine with me. So in the first one, we're going to be multiplying by 15. Second, we're going to be multiplying by 6. And the last one, we're going to be multiplied by 5. Now, we just add them up. 15 minus 36 is negative 21. Negative 21 plus 25 is 4. And we can simplify that by 2. So we get 2 over 15. Whoop. So not too scary. Last one, number 9. So follow our order of operations. So we'll do exponents first. So negative 3 squared is a positive 9. Remember that this is not the same as this. The squared acts on the thing right before it. In this first case, negative 3 squared is negative 3 times negative 3. Second one, it's 3 squared, and then it makes it negative. So you got to be careful there. Again, that's why there's parentheses, though. So we got 9 over 25. We can also multiply these two. 5s cancel out. 3s can be divided by, or 3 and 9 can be divided by 3. So if we can see all that mess in there. In the numerator, we have 1. In our denominator, we have 3. And simplifying that first gave us a lot smaller number. So that's pretty nice. Common denominator here, 750. Which may look scary. That's a big number, but again, to find what number we're going to multiply by, 750 divided by 25 is 30. So, oops, we're going to multiply by 30. So 270 here. 750 divided by 3 is 250. We'll multiply by 250 here. And then lastly, we multiply by 75, because 10 times 75 is 750. So 7 times 75 is 525. So 270 minus 250 plus 525 gives us a grand total of 545 over 750. And we can divide those both by 5 because they end in 5 and 0. So when we do that, we get 109 over 150. Kind of ugly, but nothing goes into those two numbers. Oops. What's going on here? So we're going to divide. When we simplify this, we're actually dividing by 5. So we got 109 over 150. Again, we're not going to do the dimensional analysis because that was in the Ed puzzle, and it's not going to be on our